Alright, so in this video, I'm going to be solving the equation 6 to the power of x is equal to 60. So to solve this, what I'm first going to do is I'm going to be taking the log on both sides. So I get log of 6 to the power of x is equal to log 60. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front. This can equal b times log a. In this case, I have log 6 to the power of x, and I can move x to the front. So I get x times log 6 is equal to log 60. Now from here, I'm going to divide both sides by log 6. So then these two cancel out, and I get x is equal to log 60 over log 6. So now from here, what I'm going to do is I'm going to rewrite log 60 as log of 6 times 10. And if I have something in the form log of a times b, this is equal to log a plus log b. So log 6 times 10 is going to equal log 6 plus log 10. And I evolve this over log 6. Now, from here, if I have something in the form a plus b over c, this is equal to a over c plus b over c. So log 6 plus log 10 over log 6, I can write this as log 6 over log 6 plus log 10 over log 6. Now, log 6 and log 6 cancel out, so I get x is equal to 1 plus log 10 is also equal to 1. So I have this over log 6. And if you guys already didn't know, log 6 is equal to log 3 times 2, which is equal to log 3 plus log 2, which is equal to 0.7781. So if I plug this in for log 6, I am left with x equals 2.2852. Alright, so in this video, I'm going to be solving the equation x to the power of 3 is equal to x to the power of 5. So my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution, I'm going to rewrite my equation down here so I have a little more solving space. So my equation x to the power of 3 is equal to x to the power of 5. And what I'm first going to do is subtract x to the power of 5 on both sides. So then these two cancel out, and I get x to the power of 3 minus x to the power of 5 is equal to 0. Now, from here, x to the power of 5 is the same thing as x to the power of 3 plus 2. And an important property of exponents is that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of 3 plus 2 is going to equal x to the power of 3 times x to the power of 2. And now I'm going to factor out x to the power of 3. So I get x to the power of 3 times 1 minus x squared. So Now this gives me two equations. I get x to the power of 3 is equal to 0, and I get 1 minus x squared is equal to 0. So, for x to the power of 3 equals 0, I'm going to take the cube root on both sides. So I get the cube root of x to the power of 3 is equal to the cube root of 0. The cube root of x to the power of 3 is x, and the cube root of 0 is 0. So x equals 0 is one solution. Now for 1 minus x squared equals 0, I'm going to rewrite this as negative x squared plus 1 is equal to 0. And now I'm going to multiply both sides by negative 1. So negative 1 times negative x squared plus 1 is equal to x squared minus 1. And 0 times negative 1 is 0. So I get x squared minus 1 equals 0. And 1 is the same thing as 1 squared. So I have x squared minus 1 squared is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is equal to x plus 1 times x minus 1 is equal to 0, meaning I get two equations, x plus 1 equals 0 and x minus 1 equals 0. For x plus 1 equals 0, I get x equals negative 1. And for x minus 1 equals 0, I get x equals 1. So notice how we have three equations for this equation. Notice how we have three solutions for this equation.